Did I still? Okay, I think it's recording. Hope it's recording. All right, let's see. We're gonna go on 7.2, but before we do that, any homework questions on 7.1? That's what we want to jump to. And if not, we're gonna keep on going. Yes, we have one homework question person. All right. Evidence that you guys started on your homework. That's good. Let me jump to Dylan 1 second. Let me do one more thing here. I'm going to do that. Boom. And all right, this is 7.1 homework. Go. Dylan, all yours.
47.
47.
It's not that I didn't understand how to do it. I didn't understand how to do it on a calculator.
Okay, gotcha. Yep. Any one of those, anything that you have off the homework is good. All right, we have evidence that at least one person did their homework. That's good.
They're like those.
Oh, using a graphing utility to do that, huh? Okay, you are right, Dylan. I probably should have showed you how to do that. So let's go with it here. First of all, you got to do some work. So notice on your calculators, if you have noticed, you always get a y equals. If it says y equals this, y equals that. So before we can input this into our calculators, we have to solve these guys for y. So first things first, we got to solve this guy for y. We're going to subtract x squared from both sides. And that's not too much trouble. This would be 169 minus x squared. And then we have to take the square root of those. It's not square root of individual numbers. That doesn't work. It's the square root of the whole entire term. So remember, when we are the ones that take a square root, we have to put a... We've got to put a plus or minus there, don't we? Hey. No problem. Glad you're here. And I saw your name on the little list here, so we're good. Come on in. And your test is actually on your desk, Matt.
Where's
okay.
the plus or minus button?
There is no plus or minus button.
You have to do them.
Yes. Okay. Let's go to this one and then we'll start our calculator process. So that we're just doing, and Camille, we're just doing homework questions from 7.1. 104 minus x squared. This one's going to be divided by -8. Okay, to punch in the calculator so it makes it a little easier. Oh, yes. We're going to get rid of that -8 on the bottom. I'm just going to mess it up. So raise your hand if you need a calculator. Graphing, We're going to have to do by graphing, yeah. And if you guys, when you come in the classroom, if you want to just grab a calculator, that's fine too. There'll be in a little cubby hole. All right, let's jam this one. Only thing I don't like about it is this right here, that little negative. So let's take the negative up to the -104 and to the -x squared. So this should give you a -104 plus x squared, or turning it around, that's the one we want to plug into our calculator. Good there?
Wait, but then wouldn't it still be over 8?
Over 8. Thank you. So that one. So this is the particular one right here, is that we're going to have to choose a plus and then also do a minus to get us that. So a few things to do by calculator. Please tell me if you need to slow down, if you want me to slow down, if you didn't get the screen before, just so we got it. This is not me running through it and not showing you stuff here. This is for you guys. So first things first, this guy over here. So on button, clear button. Let's see if I am that. Yep. So we're going to do this. We're going to say square root of 169 minus x squared, and close that guy off. That's going to be one part of our equation. We still have the negative one in there. So this little negative sign right here, I'm going to put negative. Square root 169 minus x squared. Okay, so we have the positive and the negative. The calculator, you have to do that because the calculator can't do, it's called implicit equations. It actually does explicit, which means solve for a variable. Okay, then we have the other one. This one's going to be parentheses because this whole entire thing has to go on top. Parentheses of x squared minus 104. Close off the parentheses, divide by 8. There's that one. Okay, good so far? And you guys, again, talk to me, slow me down if you need to, okay? Click enter, just so that is entered. And then the graphing window is normal. So as you graph it, it looks like this. That's not cool. Okay, let me see yours here. So those of you that are, let me at least get you guys to this graph here. You're gonna have to zoom out eventually.
So this is what I'm entering, and then when I hit graph, it says window range. Okay, gotcha. Click on window then. You have one that's higher than the other. So see how your max is positive and min is negative. Switch those around. Go negative to 10, and then go by ones instead of 20s. On scale? Yeah, scale. Yeah, this type was used by a different class, that's why. So negative 10 to 10 again. 10 by ones, okay, perfect. Okay, now graphic. Let's see what we get.
All right, graph-wise, are we good?
Wait, is this?
Yeah.
Zoom out more?
Absolutely, yeah, when you zoom out, we're gonna get that right there. So a few things we gotta see. And let me zoom out. So real quick here, those of you with the zoom, click on zoom, click on zoom out, which is number 3. So this button here, zoom out is number 3. And usually it starts out with 0, 0. That's the one I wanna zoom out on. So here's what I got now. Here's my top circle, my bottom circle, and now my parabola that comes across. We good?
How did you get yours to zoom out like that so fast?
Sure, zoom and number 3.
No, but like when I hit my zoom out, it doesn't really do anything. It just sort of.
Ah, you're in a different zoom. Let's see.
Yeah, how do I change that?
No, no problem. You guys ask me as we go. Those are ahead of me right now. Try to see if you guys can find the answers here. Interesting.
What are we trying to find?
Intersection points between the two. Number 3. Yep. Oh, okay. You gotta click it twice.
Oh, okay.
So when you click on zoom out, let me show you. You click on zoom out, you click on it. It has 0, 0, and it's kind of what's the center you want to zoom out from, and then it gives you that.
Got it.
But I don't see the circle. That's why the weird thing is. See, oh, gotcha. See how the equal sign is highlighted here? But it's not highlighted on those. Highlight these, you're not graphing them, so just click enter. Enter, and now you've got one. And the other thing is, funny. Oh, okay. It is. Okay. Yeah.
Let's see. This one. Oh, click it out.
Also, my dad thought it's supposed to be in the morning.
There's one line.
It starts in the morning.
I want to do a line.
There's a one. It's weird, but we never even get here at the.
Mm-hmm.
There's always like 20 to 25 minutes.
We're not gonna
Which
get
is
all those.
way
We
too
did that all
long.
last year, so we're-
I was sitting on the pod. I was like, oh, I'm in action.
She had to mark it on Saturday, she marked the form.
You know what?
She owns it. It's
That
very
is so weird.
Buddy.
I will play with it a little longer here, so I'm.
Yeah.
I think this one, the house is at better.
No, it's all there.
Is there like a way to reset? Did we?
Yeah, it should be right here.
I mean, where is that?
Because you give you all the different options,
Really well.
Also for the tile page,
but it's still not giving you.
Have fun over there?
Okay.
You didn't respond to my text. How was it gonna go about
Well,
today?
that's
These are-
rectangular, polar, no, grid on, grid off, access label,
What'd you say?
expressions are on,
You didn't even.
trail on.
What
Okay.
about you?
I can mess around.
Yeah, that needs to be a line. It should be a line that's
It's
kind of
probably
diagonal like this.
not
Because you have-
top of part.
If you have it in simultaneous equations, so then you go to the settings, it's in regular mode. That's the weird thing about it.
I told them.
Oh.
But it's not. You
Um,
can do?
Maybe just this right here. Can you go to expression off
On which one is that?
on format? So second zoom,
Second zoom. And what am I turning?
just turning off the last bottom thing.
Trail?
Ooh, okay, you have trail on there, huh?
Yeah.
How about expression?
Expression off? Okay.
Uh-huh.
Okay. So I'm on the same page here.
Yeah, and then all this is all correct. Let me just check something out real quickly here.
Oh my God, let's see it.
We're going to the place, right?
I'm rich.
I will have to take a look at that.
Alright.
All right, class, sorry about that. Let's go back to here. We had a calculator that was going crazy. We are gonna graph this guy. It looks like this. There's a top graph, bottom graph, and then here's the parabola coming in. We want to find the intersection point between the two. So let's do this here. Let's zoom in. Notice that there's an intersection point right here. So let's zoom in just on that. So kind of careful here. You're going to click the zoom button right here. And then what you want to do is you want to do zoom box. See the zoom box right there? Let's see how the zoom box feature works. Ready? And mark that and click on it. And you're going to have these coordinates. Don't click yet, but you can move this around like this. See this little X that starts right here? You want to be in the upper right-hand corner. We're good? And you want to click enter once. And then what's going to happen is it's going to turn into a solid level line. But what it's really doing is you're describing which window you want. So go up and down to describe that little window right there. Are we good there? So it says, I'm gonna zoom in just on that little window right there now. So real quick here, before we do that, notice it's the top half of the circle. That's our Y1 value. We good? Our bottom half of the circle is Y2. And then our parabola is Y3. So we're gonna keep those in mind because it's gonna say which one do you want to intersect with? And it could be none. Okay, we're good. So let me grab this one, enter, here it is, my top half of the circle, bottom half of the circle, and my parabola coming down. Are we good? So now what I want to do is I want to find calc. This is the calc button. It's above the trace button. So I want to do some kind of calculation with my graph. So second calc, and I want to find the intersect of it, which is number 5. I want to find the intersection point between the two. Click on number 5, and it says, hey, what's your first curve? And it's this one here because it's these two curves here. So you click on yes, and it says, what's your second curve? And so you're gonna go up and down. So kind of careful as you do this here. So first curve, I chose this guy, right? And it's gonna cycle through between y1, y2, and y3, right? Boom, 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 like this. So what you want to do is you click enter on the first curve. You click down because you want to skip this y2, and it's going to jump to y3, which will be about right here. And that will be your second curve. We're good? Because it's the top half of the circle and the parabola. That's the two you want to intersect. Okay, tell me if you guys are okay there. Raise your hand if you're okay. All right. Even if you don't have a calculator, it's still okay. All right. Enter. And it says guess. So what you want to do is you want to get kind of close to the intersection point itself. Click, and you got yourself. So negative 12 comma 5. Are we good there? Okay, that's 1. Dylan, are we good now? Cool. Okay. So now, next thing is go back to Zoom. We're going to play around with it here. So now we got to do the bottom half over there. So you might as well just go back to Zoom and do standard, which is going to take you from negative 10 to 10 again. Okay.
Was it negative 12 and 5, and then you just flip this where it's 12 and 5 as well for the other side?
Ah, cool, cool. Yes, true. Because it's thinking about the fact that it's symmetric on both sides. Yes. Let's go back to Zoom standard, which is number 6. Click on 6, and you're going to get to this one right here, which is the original graph we did. And then what you want to do is you want to zoom out again, which is what we did. So zoom out. So click on 3. It's going to say, what's your center of your zooming out is 0, 0. Click on it again. Here's my top half of the circle, bottom half of the circle, and parabola. And now we want to zoom in on this little part right there. So notice it, I think it touches, it may touch right here. It's that bottom of the circle right here. So I'm going to go zoom again, zoom box. And I want to put my arrow about right here, top right-hand corner, click enter, and then make our window. It doesn't have to be symmetric either. It's just a window that's made. Click enter. Okay, there's the bottom half of the circle, and there's the parabola. If you want to, you can actually go like this with this little cursor here. That's kind of close there. But let's go with it. Calc again. So second calc, we want to find the intersection point, which is number 5. So number 5 for intersection point. First curve. Click down arrow. So notice the first curve, the cursor is not even, the little blinking cursor is not even there anywhere, because it's going at y1. It's the upper half of the circle. We don't even have that in our window anymore. So click the down arrow, and notice this guy appears. Dun, 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 dun. There it is. That's y2, which is what we want. Click on that. Then it's going to jump to the second curve, which is the parabola that we have. So click on that. And then it says guess. So you're going to go right to where you see that they're almost touching each other right over here. So click enter on the guess. And what did you guys get for the answer? Nope. 6 more than that. 7 plus. Oh, how fun is that? Anybody got that? Like a negative 7.5 e to the negative 6 or something. Okay, what does this mean? The X value, I got a strange value. It's negative 7.5 e to the negative 6. So along the x-axis, what it's saying is, it's saying it has, it's a negative value. So negative 7.5 e to the negative 6 means you got 1, 2, 3, 4, 5, 6. It's kind of like scientific notation right there. That's what this is. All right, guys, what do you guys say? Is that a number very close to 0?
Yes.
Yes. Okay, so our next intersection point is 0, comma. Oh, I forgot to see what the y value was. Oh, negative 13. So you guys talk to me. What was the first one? First one was what? 5, negative 12 or negative 12, 5? Negative 12, 5 was this one. That's one intersection point. That's the next one. And Dylan said something important. He said the fact that, you know, because circles are symmetric, parabolas are symmetric, the next one we should get would be a positive 12, 5. So let's see if we get there. So zoom. We're going to go back to standard, which is number 6. Zoom standard. We're going to go to zoom out again. So number 3. So there's my top half circle, bottom half circle, and parabola. This time we're going to focus on this one right over here on this side. And let's see if we get positive 12, 5. Let's see. So zoom now, and then we're going to do a zoom box now. So I want to be able to see this little interchange right here. Doesn't have to be super close, but just enough that we get a nice box so we can see everything that's happening here. I'm going to make my box a little bit bigger this time because I want to see more of the graph. Zoom box good. Your box will be slightly different than mine. So clicking enter, here it is, top of the circle, bottom of the circle, and parabola. So I want to get this one right here. So this is y1, this is y2. I don't care about y2 this time. And this is y3, so I care about y1 and y3. So let's go to calculate. So we're going to calculate the intersection of the two. So number 5. So click on number 5 or use your arrow keys to get there. So right here is first circle, the first curve, yes. Y1 is your first curve. Click enter. Second curve, no, I don't want that one. I don't want the intersection point. So click on the down arrow to get you to y3. Click enter. Those are the two that you want. It's these two right here. Notice you have the plus signs on both of those. The guess is going to be when you're pretty close to that intersection point. Dan Dylan was right. It's 12,5. Dun, 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 dun. Okay, 12,5. Yes, I did not show you that on the notes here. So good job in finding that out and trying it first. Okay, talk to me, everyone. Are we good homework wise? Any other questions off homework? No. Okay. So let's jam with, let's see, 7.2. So 7.1 was something called substitution method. Is that right? Oh, man. Okay. And it was linear and nonlinear equations. That's cool. 7.2 is called the elimination method. So we're in 7.2. It's called two variable linear systems. So notice we're jumping around a little bit here. Notice in 7.1, we actually dealt with linear and nonlinear, right? We dealt with straight lines and curves. For the next two sections, and substitution is what we do for nonlinear and linear. So if there's a connection between the two, we like to use substitution. That helps. For elimination method, and if you want to put next to it, actually that would probably be best here. elimination method. This one was substitution method. Substitution method, there it is. For elimination method, we only work with linear functions. So you're not going to have x squareds in here, no y squareds, no x cubes, just linear fashion. Okay, so let's begin. Let me jump to, and those that find it easy, I got some challenge problems in here for you as well. So let's see how that works. So let's jam. Elimination method, the easy one example, just to get us started. Let's go. Don't need to write all this down. Just the fact that we're going to work with the elimination method this time. And you don't need to write, don't write the header for these. Just example one is just fine. So solve the system of linear equations, and here's our two systems. And you guys will have this little, these called braces right here. Just means it ties the two equations together. So solve the system of linear equations. Example one. Okay, what is the elimination method? Again, review of algebra 1. This is easy stuff. Now what we want to do is we want to eliminate one of the variables. The way we eliminate one of the variables is we just add these equations together. And we get this from pre-algebra, because if we go back to pre-algebra, we say to ourselves, look, if 3 is equal to 3, everybody true? And 5 is equal to 5, that's true. If I were to add both sides of these equations here, so notice this one turns into an 8, and this one turns into 8, and notice I still get an equal sign. So from pre-algebra, you're like, oh, that's easy. So it doesn't matter, as long as the two equations are equal, or the sides of each of the equations are equal, I can add those up together. So let's add this up. What is 3x plus 5x? 8x. What is 2y plus negative 2y? Yes, that's the guy that just got canceled. Awesome. 4 plus 8 is 12. Of course, there's going to be fractions inside here, because that would not be fun if there weren't any fractions inside here.
The fractions, do we keep them as improper fractions? Or?
We keep them as improper, So divide by 8 to solve here, and I think I can divide both of those by 4. How about a 3/2? Just like we did with substitution, once we get one, we're going to plug it back in to get the other. Does not matter which one you plug it into. Just pick one of them. And so I'm going to choose the top one. So 3 times, and then also careful here. Notice which one you have solved for. That's the one you want to plug in. So don't plug into the y, plug into the x. All right, this is where solving equations comes in handy here. Let's see, for this one, 3 times 3 is 9. So we got 9 over 2 plus 2y is equal to 4. Abe, talk to me. How would you solve this guy? Minus 9/2 is just fine. Okay, I got to do a little bit of work over here though. So 4 minus 9/2. Common denominator, is that right? Yep. I need 2 now as a common denominator. 4 minus 4.5 works just fine as well. So a little bit of work there. I got a negative 1/2. Maddie, all yours. Sorry. Just to pick on people as we go. Yeah, this is, you guys getting a little tricky here. So divide by 2 on this side. What should we do over here? Still divide by 2? We just kind of write it differently, right? But still division by 2. And then eventually what happens is this guy turns into a multiplication of the reciprocal, right? You multiply that way. Done. Okay. Can we check our answer? If we wanted to, we can check our answer. Absolutely. But our answers are 3/2, comma, -1/4. Are we good? Don't have to graph the equation. Just solve and you're done. Okay. Raise your hand if you find this like super easy. This is, geez, that was so easy. I mean, this is so. Okay. All right. So then I'm going to stick a challenge problem in our lecture here. So if you thought that was easy, I'm just trying to already know this stuff. This is no fun. I don't need to practice any of this because the next 3 problems we're going to practice with it. But those of you that send this video, I don't know the answer to this either because I haven't solved it yet. So if you want to work on this while we do the kind of review of the elimination method real quickly here, go for it. So find the value k. This is chunk problem number 1. There's another one in here too, but can you find the value of k so that the system linear equation has no solutions? And what does that all mean? And this is close to a, this is probably on par with like an SAT question or something. I think I'm gonna throw those at you. Cool. So if you want to challenge, go for it, write it down. If you don't want to challenge, then let's keep going to example number 2. Oh, and actually I have to take out a pencil. Wow. Look at that achievement. Yes, I made Owen work.
This is starting to sound like Jesus. You're gonna ignore your squares.
We'll let Owen write it down.
Not really well, my hair's kind of
Okay.
I literally did that like
I
last
know,
week.
we get a new one. Oh, so I
We almost all of them.
All right, let's jam. So as you guys are doing that, let's go with the rest of us. We're going to try to work with these guys here. So exercise 2, solve the systems of equations here. Let's go. This one, notice when we canceled off the y values, they were exactly opposites of each other, right? That was fun. There's no opposites of each other here. So what should we do to make opposites of some kind of variable? Yep. Awesome. Yep. What we do is we show arrows like this. We say this guy is going to be multiplied by 3. Technically, what we're doing is we're just multiplying the left side by 3 and the right side by 3. That's kind of what we're doing. Notice the top, there's no change. Some textbooks, they just put no change. So NC. So I got 2x minus 3y is equal to -7. No change for the top. The bottom one gets multiplied by 3 everything. So 3 times 3x is 9x. 3 times y is a positive. Oh, there it is. That's exactly what I wanted right there. I want those guys to be opposite. Don't forget to multiply the other side though. All right, can you guys finish it off? Go for it. And -2, 1 should be the answer. -2, 1 at the end. If you got -2, 1 or getting it, you're doing great. Israel, did you get it already? Okay. So let's add. That's 11x. Eliminate. That's exactly what I wanted. -7 plus a -15 makes -22. Divide through by 11. I got x is equal to, hey, -2. Okay, plug it in top or bottom, it doesn't matter. In fact, real quickly here, guys, real quick, look at this. I can plug into the top original, bottom original. I can even plug into the multiplied original. We're good? Because it's still the same, right? I multiply the same thing on both sides, it's still getting the same answers. So, Camille, Top original, or bottom multiplied? Top, we're gonna use top, okay, because there's a 7, absolutely, has to happen. So Camille said, let's do the top equation. I'm still gonna start writing it out, so it's 2. When I get to x, I substitute a -2 in for x. Boom. 2 times -2 is -4. Adding 4 to both sides makes -3y is equal to, hey, -3. Divide through by -3, and y is equal to 1. Perfect, okay, x and y. It always goes like this. It always goes x, then the y first. So don't switch those around later on. Oh. Are we good with -1, 2? Jamming, you guys are jammers, that's cool. Okay, any questions on number 2? We're good? Number 3, so let's see. The first one we didn't have to multiply at all, right? The second one we had to multiply one of them. Third example. Let's see the progression of stuff here. All right, so let's do this here. Let's pick a variable we want to get rid of. That's the first step. You want to get rid of x? Could be y, could be x. What would give it a reason why we would get rid of one or the other? Perfect, yeah, y already has negative signs, so that helps out. So therefore we don't have to multiply by negatives. Perfect, so we have signs that are already opposite. Now we just need to get the numbers to be opposite. So Charlie, all yours. What should we do to get opposites, exact opposite values? We don't want to multiply. We want to be doing this here. We want to multiply something to each of these, so that we're going to get opposite values for the numbers in front of y. I go with, yeah, top I'll go with +4. So I put this x as a multiplier. Multiply by 4. That would give me a 12y. But notice this guy's already negative. That's awesome. So if I multiply by another negative, it'll turn positive. I don't want that. Just by regular 3. Cool. So progression is example 1, we didn't have to multiply at all. Example 2, we had to multiply the bottom. Example 3, multiply both top and bottom. That's true. So 20x plus 12y is equal to 36. On the bottom, multiplying by 3 everywhere. How about a 6x minus 12y? Ooh, anybody? 14 times 3. 42. Okay. All yours to finish off. Yeah. Owen, are you done yet or no?
No.
No? Bummer. Yeah, I caught him. This is so good. I'd be like, you just made my day.
Didn't you give me the other day too with a lot of the things?
No, he got that one. Didn't you get? Yeah, he got that one. Yeah, that was no fun. So maybe we'll do this. I'll do like trick Owen problems.
I agree with that.
Yeah.
I like this idea.
It'll be, we'll call them top problems. Top problems.
He's not even listening.
I'm listening.
All right, let's finish it off here. Let's see, adding up. Everybody okay with 26 over here? The cancellation step. Anybody 36 plus 42? 78. Okay, divide by 20. Hopefully this guy goes into the other one. Oh, perfect. Okay, exactly 3 times. Cool. Okay, da, 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 da. And I have to pick on people here. Landon, original top, original bottom, multiplied top, or multiplied bottom? Which one do you want to put in?
Original top.
Original top. Okay. And again, any one of those could be just fine. Any one is a correct answer. How come you chose original top?
This is the one I started working on.
Oh, okay. Okay, good, good. Yeah, simply, yeah, the numbers are smaller. Perfect. Yep. And then we get the negative out here. Perfecto. Let's see, subtract 15 from both sides. This guy, what, -6, I believe? Okay, divide by 3. Awesome. +3, -2 is the answer. So if I were to graph these, I'm not sure how the lines go, but I know 1, 2, 3, 1, 2. I know at this point right here, however these graphs go, right? They are going to intersect right at that point, right? That's what I know.
Oh, that's what they're gonna intersect, not what it- oh, it's the-
Cross, intersect, yeah, same thing, yeah. Okay, so now the question is what we talked about last time here. So if you have two lines, talk to me here, guys. If you have two lines, one possibility is that they intersect at a single point, right? What's the other possibility?
Hey. Intersect the wall.
They go what?
They intersect the wall.
Yeah, how do you draw intersect at multiple points? Because they have to be straight lines, right? You can't bend them or anything, right? They have to be like,
Oh, we're talking about linear.
yeah.
So,
You end up having more than two.
oh, if they're parallel on each other, or if they're like on top of each other.
Oh, yes, okay, so multiple answers would be if they're just sitting right on top of each other, like this and like that. That would be infinite, yeah. There's no such thing as just getting two answers, right? It's either one or all. And then is there a way to get,
You have none if they're parallel.
perfect, yeah, and parallel lines means that they're never gonna touch. That's cool.
So if they're on top of each other, it's infinite. If they're parallel, it's 0, and anything else is 1.
Uh-huh.
No, we're gonna end up with somewhere between one and infinite, probably, if you have three.
Yeah, there's not even really a between. It's either 0, 1, or infinite.
Uh-huh, so the book kind of lines it up like this here. So if you have, and this is on, you don't need to write this down because it'll be a long time. So just put down page 510. Page 510 for this. So notice it's like this right here, and this might help out Owen. We'll see. Number of solutions versus what it looks like as a graph versus what the slope of the lines are. So if you have one exact solution, the slopes intersect at a single point, and then the slopes are not equal to each other. That is because if the slopes are equal to each other, we're in trouble, right? Infinitely many solutions means the lines coincide, or they call identical, and the slopes are equal. I would say the slopes are equal and the y-intercept is equal. If you have no solution, they are parallel, the slopes are equal, but the y value is not equal. Okay, again, don't need to write this down, but put page 510, just so you have it with you on those. Okay, so let's do this here. We already done this one right here. We've done this already 3 times where they coincide, I'm sorry, where they have just one single answer. Let's do this real quickly here. Let's look what happens when we have the no solution case. So example number 5, let's see how much minutes we have. We have 4 more minutes. Yeah, let's do the no solution. Let's do the many solutions. I think we'll be almost done. And we'll skip the application, but at least we'll get through it. So let's go 3.5 minutes left. Let's jam. So first things first, we got to think about which variable do we want to get rid of. Dylan, or Neil, all yours. Which variable to get rid of, X or Y?
No, that X is looking like it's gonna go.
Say again, say again.
That X is looking like it's gonna go.
Okay, X gotta go. Okay, so arrow over here. What should we multiply by to get rid of X? Tristan.
I think we should do the Y. We should multiply by 2. Yeah.
Okay, hold on, Dylan, you get overruled. We're gonna multiply the what?
The top one?
The top by 2, okay? And no change for the bottom, right?
Wait, now they, yeah, now they both. Oh,
Oh,
They both cancel.
so Dylan was right as well. So how about this? 2x minus 4y is equal to 6. Everybody agree there?
7, 0 equals 7. Yeah, you cross the left, it's all 0.
Uh-huh. Okay. So cancel. That's 0 and that's 7,
Oh, yeah.
which is true or not true?
Not true.
Not true. So if you are going to do this, if you're going to we're going to have to put a slash through the equal sign. That is not true. Or else I give you $0 and you give me $7. That's a pretty
Same
cool
amount.
bargain.
Where's-
Same amount.
I wish stores did that.
So, ready for this one? It is no solution. We good? There's no solution here. Okay, 2 minutes left. Let's do the next one. And Isabel.
I think I might have done it.
Okay, Isabel.
I'm not sure now.
We'll finish up one problem here in a second. Which give me the variable to get rid of, X or Y? X. We're gonna get rid of X. What should we multiply by to get rid of X? -2 on top. Okay. No change for the bottom. So I got myself a -4x. I got myself, hold on, -2 times -y, positive 2y, and -2. Okay, this one, 4x minus 4, no change for the bottom. And let's add them up. Let's see what we get. Yes, Camille says 0 on one side and 0 on the other. That is a true statement. And our variables are gone. They just canceled themselves out. We have, we're going to call it infinitely many solutions. Thank you. Class, you guys should notice this real quick here, though. Look at this before I cross them all out. Notice the top equation. If I were to multiply that by -1, I'll get the bottom. Notice that? Right, so the two equations, why do they produce the same line? Because they're exactly the same equations. Okay, that's why they produce the same lines. So, okay, we stopped there. We didn't get to the application question, and we didn't get to the decimal one, but we'll handle that on Friday. As we put things together. Enjoy the rest of your day, and Owen has to see if, Owen, tell me if you